next parameter you can edit is thunderstorms. When it comes to thunderstorms editing, it is quite a complex concept. So maybe the best approach is to use existing theory about the thunderstorms. For example, in tropics, GDI index might be the best approach. You can find more information about the GDI index and how to calculate it on the internet. And many of these parameters are available on SmartMet, or you can calculate them using SmartMet and SmartTool language. It requires a little bit of time, but it's not impossible. So for example, here is one example of almost GDI calculations that, into addition, the normal GDI calculations are also taking into account topography. So it's making corrections over the mountain, for example. Take your time. So remember, whatever you're doing, it doesn't have to be ready now. So you can take your time and do your research at your own pace. And remember to share your results with your colleagues as well. In Finland, because GDI is not working for us, since we are not in the tropics, we have our own calculation system and we have different versions of that. So we can use, for example, ensemble information and the probability information available from the models directly. So in order to visualize anything, you have to have a script that creates the parameter called thund. This is the parameter you can edit the probability of thunderstorms. So for example, with the GDI calculation, your final results needs to be something related to thund. So for example, in my GDI example, we had thund as a variable in the end of the script. And when you have created your thunderstorm field, what you can do is to modify that existing thund parameter. So for example, you can reduce the amount of thunderstorms if the precipitation intensity is weak. So for example, in this case, if the precipitation intensity is less than 0.1 millimeters per hour, and for some reason probability for thunderstorms is over 20%, you can reduce it to 20%. And of course, one way to force thunderstorms there is to make circle selection. So you can paint the area that you wish to add the thunderstorms to. And what you can do is just to write down. This is just an example, and I run it only for today. This looks very weird and patterned. It's because I'm using the function run. But if I use the script I showed you earlier and run this, it will reduce the amount of thunderstorms only to these areas where we have some precipitation according to the model. At this time of year, we don't have any thunderstorms in the whole Scandinavian area, but it doesn't matter because how you deduct the probability for thunderstorms should be country specific. So if you're in tropics, I would suggest to look for the GDI index and see what you can come up with using that index. So I'm gonna undo this because it's not making any sense to this time of year. And then we can talk about another parameter that is called probability of precipitation. That is also very country specific, and you should create that parameter as well because it's not there as such, but might be a good parameter in some final products, for example. And for that, you can refer to edited data, something like this. This macro is creating probability of precipitation around the precipitation. So that whenever we're seeing precipitation, it takes an area around it. And then using the ramp function is decreasing the probability further you go from the area of precipitation. So what it might look like is, for example, for this situation, so today 18 UTC, it might look like this. So it's a little bit extending away from this area of precipitation, but mostly it is following the pattern of that precipitation intensity. And probability of precipitation is abbreviated as POP. So with the help of that, you can first create the variable and then you can continue working with that. And once again, this is very area specific. So you can take, for example, topography, coastlines, higher terrain overall into account when manipulating the value of this parameter. So for example, in one of the tropical countries, they used to have a macro like this that was taking different models into account, also previous model runs, and then doing some calculation and finally assigning a value to the variable pop. So you can try to do calculation for probability of thunder as well as probability of precipitation. And they don't need to be ready immediately. You can continue fine-tuning those and see how it works in different situations. And then you can keep modifying it. But meanwhile, you can start to use it. Because only when you are using it, you might get some necessary feedback from your colleagues, for example, or your customers, if it's working well or not. So try some calculations and then verify it, how it's performing, and it should be just fine. Just remember that thund is probability of thunder, so it has nothing to do with exact thunderstorm forecasting as such. So when you're forecasting thunderstorms, do not rely on any of the indices only, and try to look for ingredient-based methodology. In that way, you are also able to forecast the impacts and the uncertainties, for example, related to the initiation of the convection. So those are a little bit two separate things: to edit the probability of thunderstorms and to forecast if the convection is initiating or not and how strong it might be. If you're using an existing theory for thunderstorms, for example, try to use the same kind of visualizations. So for example, with the GDI index, it has interpretation and the visualizations that goes like this in a table. So the index value is presented with these kind of colors. And what you can do is that you copy paste those colors using SmartMath, and you can get visualizations that are very nice and easily comparable between different models.